Welcome to video 2, Production Possibility Frontier, Production Possibility Curve, Production Possibility Model, an important building block of economic thinking. Please be certain you watch the first video on Production Possibility Model prior to moving on to this second video. Quick review of the reasons why economists believe the Production Possibility Model is vital to understanding the foundation of economic thinking. The model demonstrates the limitations of economic production for a specific time. The model illustrates graphically and numerically the idea of choices, trade-offs, and cost. The model introduces and explains three types of efficiency: full employment, productive efficiency, and allocative efficiency. And then the model examines the possibility of economic growth moving forward. Be certain that you understand these types of efficiency: full employment, using all of your available resources, society putting to work all of its available resources, land, capital, labor, and the skills of the entrepreneur. Productive efficiency, producing a good or service using the least cost method of production. Don't overuse resources to produce a good or service. And finally, allocative efficiency, the mix of output, the combination of production that maximizes society's happiness or utility. All of these slides are review, including this last slide of review. All production possibility frontiers are built on four assumptions. The production possibility frontier, the curve, the production possibility model represents the idea of maximum level of production for a specific time period. Anywhere along the curve, anywhere along the frontier, society is achieving full employment and productive efficiency. So we assume that to maximize our potential output, we will put to use all of our available resources and produce using the least cost method of production. For the time being, both in quantity and quality, society has fixed resources. Technology or the methodology of production is also fixed for the time being, and every production possibility frontier has an X and Y axis, and therefore examines the trade-off between two types of production. We will be moving on to a macroeconomic example in the near future. However, we will start our examination of production possibility model using a microeconomic example. This is referred to as the SARA study world. All right, what are we measuring? On the horizontal axis, we're measuring expected grade in economics for a student named Sarah. And on the vertical axis, we are measuring expected grade in accounting. Now, here's the deal with Sarah. She has not been such a good student. She hasn't been very diligent about her studies. As a matter of fact, she has procrastinated all studying for her courses until the night before the exam. Now, the good news is that her final grade for each course will be 100% determined by the result on the exam. The bad news is that she has exactly 10 hours left to study. We can construct a production possibility frontier for Sarah's potential outcome of her accounting grade and economics grade based on the assumption that she will use all of her 10 hours for studying. So if Sarah allocates all of the 10 times 60, 600 minutes to studying accounting, she will do spectacular in accounting, earning an A. Unfortunately, the trade-off of that choice will involve failing economics. A for accounting, F for economics. I assume you can see that outcome. Vertical axis A, horizontal axis F. Well, maybe Sarah would like to shift some of her time away from studying accounting, maybe allocate 2.5 hours towards economics and only 7.5 hours to accounting. The good news is that her economics grade improves from F, a flunk, to D. But the bad news is she can't have more of both, right? Choices, trade-offs, and costs. The choice of allocating 2.5 hours away from studying accounting and into studying economics is that her accounting grade falls from A to B. I think you can understand that we can therefore construct a production possibility frontier based on Sarah's choice of allocating her 10 hours of study. She could choose the other extreme and study just economics, no accounting, and she would receive an A for econ and an F for accounting. So we've now constructed Sarah's production possibility frontier. An important economic observation. Any time a student witnesses a linear production possibility frontier, that is to say, if the production possibility frontier graphs as a straight line, an important economic principle or concept is being conveyed, and that is what economists refer to as constant costs along the curve. In other words, the opportunity cost of one outcome relative to the other outcome remains the same along the entire production possibility frontier. Why is this the case? Okay, Sarah is one person studying two subjects for which she is equally adept at performing this task. Assume that I am Sarah and I'm reading my accounting book. Well, we use seconds to represent hours. I'm reading my accounting book for 1, 2, 3, 4, 5 hours. I put that book down, I pick up the economics book, and I read that for another 5 hours. So it's one person performing two highly similar tasks. Therefore, there is constant cost along the curve. In other words, the opportunity cost of one outcome, in this case accounting grade versus economic grade, remains the same. In this example, it's a one-for-one trade-off. One higher grade in economics is only achievable through one lower grade in accounting. It doesn't necessarily need to be a one-to-one ratio. It's just that the ratio would always remain the same if the production possibility frontier is linear, graphs as a straight line. This linear production possibility frontier will be re-examined later in the course when we talk about international trade. Now, what specific allocation of time would maximize Sarah's utility / happiness? Well, if we look at the middle ground, 5 hours of accounting and 5 hours of economics, this combination allows Sarah to pass both courses. She achieves a C in accounting and a C in economics. If her parents would have given her a difficult time for getting anything less than a C, this will be a good outcome. If she would have to repeat a course for a D or F grade, this would be about a good outcome. All right. Now, other things equal, we don't know Sarah's situation. We could assume that 5 hours of accounting and 5 hours of economic studying represents allocative efficiency, the one point on the curve, the mix of output which maximizes Sarah's happiness. Perhaps she's an accounting major and the econ class is an elective and not necessary even for her graduation. Therefore, she would not choose that point. She would choose to allocate all of her time to studying the accounting. But without any further information, we could reasonably assume that 5 hours of accounting and 5 hours of economic studying is the one outcome that represents her mix of choices that maximizes her happiness. Let's introduce an additional example of a linear production possibility frontier to reinforce the important idea of constant costs along the curve. This production possibility model measures agricultural output in Canada. Potential wheat production is measured on the vertical axis, and potential corn production is measured on the horizontal axis. This production possibility frontier only measures potential agricultural output in Canada. It is only a representation of the farming industry. It's important for students to note this production possibility curve does not represent Canada's potential economic output as a nation. Again, it's only measuring agricultural output and the trade-off between wheat production and corn production. Remember, if a production possibility frontier is linear, if it graphs as a straight line, it demonstrates constant cost along the curve. That is to say, the opportunity cost of one product measured in terms of the other product remains the same along the curve, and vice versa. Why can we assume that the production possibility frontier for the agricultural industry in Canada is linear? A linear production possibility frontier assumes that the economic resources necessary to produce these products are readily adaptable or shiftable. In other words, the land, capital, and labor used in the production of wheat could be easily adapted to producing corn, and vice versa. For this reason, this production possibility frontier is linear, graphs as a straight line. How do we measure the opportunity cost of wheat in terms of corn? Or how do we measure the opportunity of corn in terms of foregone wheat? Remember, if Canada wants to produce more wheat measured in bushels, the only possible means to produce more wheat is to give up corn production, because production possibility model demonstrates limitations, choices, trade-offs, and costs. There can be no possibility of increasing the production of wheat and corn simultaneously. The answer for opportunity cost is already provided on the slide. However, it's important for students to be able to independently calculate the opportunity cost of one product in terms of the other product. How do we calculate the opportunity cost of a bushel of wheat in terms of foregone corn? Or how do we calculate the opportunity cost of corn in terms of foregone bushels of wheat? Let's start by calculating the opportunity cost of a bushel of corn. Assume for the moment that Canada allocates all land, capital, and labor agricultural resources towards wheat production. This vertical representation at 120 bushels of wheat represents the maximum level of output possible in Canada for this given time period. Canada would never be able to produce greater than 120 bushels of wheat. Let's assume for a moment that they wanted to shift all production away from wheat and towards corn. So Canada will give up 120 bushels worth of wheat production to increase corn production by 20, the maximum level of corn production. So all land, capital, and labor in the agricultural industry is now allocated towards corn. 120 over 20 equals 6. It's important for students to note, when calculating opportunity cost, whatever product you are getting, put that on your denominator. Whatever product you're giving up, put that on your numerator. In this case, Canada forgoes 120 bushels worth of wheat production to increase corn production by 20 bushels. Therefore, the opportunity cost of each bushel of corn is 6 bushels of wheat. Remember, this cost remains constant along the curve. The first bushel of corn cost Canada 6 bushels of wheat. The second bushel of corn cost Canada 6 bushels of wheat, and so on, all the way till we get to the 20th bushel. Because this production possibility frontier is linear, to calculate the opportunity cost of the other product, in this case wheat, in other words, how much corn does Canada need to give up if they want to increase wheat production, we simply invert the fraction. Use the same logic as employed before. Assume for the moment Canada was just producing corn, 20 bushels. Now they want to shift all resources away from that type of agricultural output into wheat production. 20 over 120. Canada is giving up 20 bushels of corn to increase wheat production by 120. 20 divided by 120, the opportunity cost of a bushel of wheat is 1/6 of a bushel of corn. Remember, Canada would most likely choose some point in between wheat production and corn production as allocatively efficient. This concludes the second video introducing students to the economics of the production possibilities model. Look forward to discussing more economic ideas related to the production possibilities model in the third video.